Now, I'm dealing with the exercise 2.1 of class 9 polynomial chapter. This is the second chapter and it's a solve. I have solved this whole exercise for you all. Now let's begin. See, this is the first exercise 2.1 of the chapter polynomials. The first question is, which of the following expressions are polynomials in one variable and which are not? State reason for your answer. Here, there are few polynomials given. I have to tell this. So before we start solving them, let us see what is the required information. Now, see, this is a note. An algebraic expression is a polynomial if the power of the variable is a whole number. That is, it should have 1, 2, 3, 4. Only those two numbers should be there. It should not be a negative number. -1, -2, -3. Nothing of that sort should be there. The power of the variable should not be a negative number. It should not be a fraction. That is, it should not be 2 by 3 or -1 by 5 or any fractional number. So no fractions, no negative numbers, only whole numbers. So starting from 0, 1, 2, 3, 4 up to infinity. Okay. Then we say it is a polynomial. The polynomial using only one variable means only one letter is used, either x or z or a or b or whatsoever, and only one letter is used throughout the polynomial, then we say it is a polynomial in one variable. Otherwise, it is a polynomial in two or more variables. Okay. Now, first, let us start with the solution. See, let's take the first one. See, 4x squared minus 3x plus 7. Here the variable used is only x. Only x is used. There is no other variable. And the power is a whole number. This is the power, which is a whole number. Here the power nothing is means 1. So 1 is also a whole number, 2 is also a whole number. Therefore, the power is a whole number and the variable used is only 1. Therefore, it is a polynomial in one variable. Am I clear? Now let us consider the second question. See, what is the second question? Y squared plus root 2. Number 2, the power is a fraction. Root 2 means 1 by 2. Power of 2 is a fraction, but it's not a variable, it's a constant. Variable is only y, and the power is 2, which is a whole number. So here the variable used is only y, and the power is a whole number. The constant can be a real number. So this number can be any real number. It can have roots, cube roots, or fraction, whatever it is. This can be anything. Therefore, this is also a polynomial in one variable. Only variable is used is 1 and the power is 2. Okay. Now let us take the third one. Third one, t is a variable. T is a variable, but this t is inside the root. Square root means t raised to 1 by, that means the power of the variable is a fraction. Therefore, it will not be a. So here the variable uses t and the power is a fraction. And the constant can be a real number. This constant can be a real number, but variable cannot be. The variable cannot have a fraction as its power. Therefore, it is not a polynomial. Next, y plus 1 or 2 upon y. This y is in the denominator. So exponential law says that when you write it in the numerator, it can be written as y raised to -1. So it is y plus 2 raised to 2 into y raised to -1. So here the power of the variable is negative. Though variable used is only one variable y, but the power of the variable is negative. So here the variable used is only y, but the power is negative. Therefore, it is not a polynomial. Yeah. Next, x raised to 10, y raised to 3 plus t raised to 50. X is a variable, y is a variable, t is a variable. The powers are all whole numbers. Okay. So there are three variables are used here. So here the variables used are x, y, and t, and the power is a whole number. Therefore, it is a polynomial, but it is a polynomial in three variables. Okay. So it's a polynomial in 3 variables. Yeah. That's how you should be able to differentiate. So the starting note, what you have written there, that you remember, you will be able to answer the questions. Now question number 2. Write the coefficient of x square in each of the following. Now what is it? Coefficient of x square. Here notice coefficient of x square is a number in front of x square. Number in front of the x square is the coefficient of x square. Let's take the first one. Now here if x square is this is x square, there is no number in front of it. If there is no number in front of it, means you have to take it as 1. That means the coefficient of x square is 1. Number in front of x square is 1. So the coefficient of x square is 1. Second one, 2 minus x square plus x raised to 3. He has asked you only coefficient of x square. So we have to focus only on x square. And here there's a minus sign in front of x square. Therefore, the number in front of x square is minus 1. So the coefficient of x square is minus 1. Third one, 5 by 2 x square plus x. So it is clear that number in front of x square is 5 by 2. So the coefficient of x square is 5 by 2. So the number in front of x square is 5 by 2. So the coefficient of x square is 5 by 2. Root 2x minus 1. Now, here coefficient of x square is asked. Here there is no x square term at all. So when there is no x square term, we can presume that the number in front of x square is 0. Therefore, 0 into x square has become 0. So we can say that number in front of x square is 0. There is no x square term in this expression. So the coefficient of x square is 0. Presume that x square 0, so 0 into x square is 0. Therefore, there is no x square term. Clear? So that's how you decide whether if the x square term itself is not there, then you simply write coefficient is 0. Next question. Give one example each of a binomial of degree 35 and a monomial of degree 100. Okay, let us see what's a binomial, what is the degree, and what is a polynomial. See the note here. Monomial is an expression having only one term. Binomial is an expression having two terms. Degree is the highest power of the variable in the expression. This much knowledge you need to know to solve this expression. He has asked you to give one example. I'll give you more examples so that you just get better idea. That's all. Yeah. Now, binomial of degree 35. Binomial of degree 35 is it should have two terms. Binomial means it should have two terms. So this is one term, this is one term. And degree means the power of the variable. Power of the variable is 35. So this is a binomial of degree 35. Here, variable I'm using is only y. Root 2, y raised to 35 minus 4. It's having only two terms. And the power of the variable is 35. Therefore, it's a binomial in degree 35. It could be like this also. 7 x raised to 35 minus 6. So, you can have any power, real number in front of x. X raised to 35, they all are binomials. Okay? They have asked you one example, I've given you 3 here so that you have better understanding. Next, monomial of degree 100. Only one term should be there. The monomial of degree 100 is 5y raised to 100. Only one term. And the power is 100. Because the power of the variable is 100, therefore it's a monomial of degree 100. Only z raised to 100. It is a variable z with power 100, therefore it's a monomial of degree. Root 2 x raised to 100. This is also a monomial of degree 100. Clear? So for every question, see what is the knowledge you require to answer the question. Our next question. Write the degree of each of the following polynomials. Now, again, what is the degree? Degree is the highest power of the variable in the expression. Highest power. Okay, it may have different powers, but highest power. Now see here, first one. The variable is x only. Here the power is 1, here the power is 2, here the power is 3. Highest power is 3. Therefore, degree of this polynomial is 3. Variable used is x and the highest power is 3. So the degree is equal to 3. Take the second. 4 minus y square. 4 minus y square. Variable used is y. Highest power of power is 2. So its degree is 2. Third one. 4t minus root 7. Variable used is t. And the highest power is 1. Nothing is written as it's in the place of power means you have to take it as 1. So the degree is 1. Now, this particular number is a pure number. It does not have a variable. If it is not having a variable, then it does not have the variable means its degree is 0. No variable is used. So 3 could also be written as 3x raised to 0. Because x raised to 0 is 1. Exponential laws tell you. So 3x raised to 0 is 1. So 1 into 3 is 3 only. So and its highest power is 0. So the degree is 0. So degree of every constant is 0. Every number, only a number is written. It could be any real number. Then degree you will have to write it is 0. Next. Classify the following as linear, quadratic, and cubic polynomials. So what you need to know, degree is the highest power of the variable in the expression. Okay? Highest power of the variable in the expression is the degree of the polynomial. A polynomial of degree 1, we call it a linear polynomial. If the polynomial is of degree 2, it is called a quadratic polynomial. And if the polynomial is of degree 3, it is called as a cubic polynomial. Okay. So you have to see the degree. And from the degree, you will decide whether it is linear, quadratic, or cubic. So let's take the first one. X square plus x. Highest power is 2. So degree is 2. If degree is 2, it's a quadratic polynomial. Therefore, degree of the polynomial is 2. So it is a quadratic polynomial. Take the next. X minus x raised to 3. Here, highest power is 3. Degree is 3. Therefore, it's a cubic polynomial. Degree of the polynomial is 3. So it is a cubic polynomial. Next. Y plus y square plus 4. Here, power is 2. The degree of the polynomial is 2. It's a quadratic polynomial. 1 plus x. X means x raised to 1. So power is 1. So degree of this polynomial is 1. It's a linear polynomial. Degree of the polynomial is 1. So it is a linear polynomial. Next. 3t. T raised to 1 it is. The degree of the polynomial is 1. So it's a linear polynomial. T square. T square. Degree of the polynomial is 2. So it's a quadratic polynomial. 7x raised to 3. Power of the variable is 3. Degree is 3. It's a cubic polynomial. Okay. So now I give you a few practice exercise based on what you have learned so that you know what knowledge you require to answer the similar type of question. Questions are almost same. Only the examples are different. Now you'll have to solve them. Try to solve them and right? I will answer these questions in my next video. That is when I'm giving another second video of exercise 2.2. First, I will solve this exercise, practice exercise, and then solve your textbook questions. Okay, I think I'm clear now.